chapter called electromagnetic induction. Now students, in this particular module, we'll be learning how electrical oscillations are produced because of the parallel combination of inductor and capacitor. That is, we'll be learning LC oscillations. So let us start. Now students, if I consider inductor which is having self-inductance capital L and capacitor which is having capacity capital C and both of them connected in parallel, then this parallel combination will generate electrical oscillations of desired frequency. Now this is our circuit. Here we are having capacitor which is charged. Here we are having inductor and there is a key present between them and it is open right now, right? So this particular combination can produce electrical oscillations of desired frequency, and this desired frequency simply depends upon the value of inductor as well as on the value of capacitor, right? So these are the two factors on which the frequency of oscillating signal will depend, right? Now let us move further. Now let's say we are having a situation in which key is open and we are having capacitor is charged and it is charged with the polarity which is shown in this particular figure. In this particular case, the upper plate is positive and the lower plate is negative, and still the key is open. Now let's say I am closing the key right now, or I can say when key K is closed. See the diagram carefully. We are closing the key. Once the key is closed, capacitor will start getting discharged, and because of this discharge of capacitor, current will be set up in the circuit, or I can say current I will be sent through the inductor, and because of this current I which is sent through the inductor, magnetic field energy will be generated, or rather magnetic field will be generated around the inductor coil, and this magnetic field will be generated very slowly because of the back EMF which is induced in the coil, right? Now students, in this particular situation, once capacitor is completely discharged, the value of magnetic field energy around this particular inductor coil is maximum, right? Or I can say total electrostatic energy which was stored in the capacitor, now it got converted into magnetic field energy of the inductor, right students? So this is the situation that we came across. Now let us move further. Now over here, now capacitor is completely discharged, so there is no energy inside the capacitor. So the only energy in the circuit is the magnetic field energy, right? And this particular inductor coil is having back EMF, and because of this particular back EMF, the direction of current will be reversed, and because of the reversal in the direction of current, capacitor will start getting charged in the reverse direction. Now see carefully. Initially current was moving in clockwise direction, now it is moving in anti-clockwise direction, and because of this, capacitor is getting charged in exactly reverse direction, right? After some time, the total magnetic field energy which was produced around this inductor coil will be used up, and that energy will be used up to charge the capacitor, and thus again we can say total magnetic field energy which was generated around the inductor again got restored in the capacitor in the form of electrostatic energy. Now again capacitor is completely charged and there is no magnetic field energy, so thus capacitor will get discharged again, but this time it will send current through inductor in exactly reverse direction, right? Now see, the direction of current is reversed. Earlier it was clockwise, now it is anti-clockwise. So this current which is getting generated due to the charging and discharging of capacitor, this current is basically referred as AC current, or it is also referred as oscillating current because the polarity of current is changing. And why it is changing? Because of the charging and discharging of the capacitor. So these oscillating signals are generated by using inductor and capacitor in parallel combination, and the frequency of this oscillating current simply depends upon the value of self-inductance L, and it also depends upon the value of capacitor having certain capacity, right? So students, in this particular module we have discussed the concept of LC oscillations. So that's it for this particular module. See you in the next module. Till then, keep learning.